All right, this is a picture of Garner, North Carolina. And when I was a grad student at the University of North Carolina at Chapel Hill, I was taking classes at NC State. And they took me to the site back in '93, and there were no trees because it was just getting planted. You would know that I'd be back working at this site at NC State if you, as a crow flies, follow this road a little mile beyond this actual facility and the trees. It's part of the network that the city of Raleigh uses to treat wastewater in Reed County. So I'll be talking about this site and other sites in North Carolina. Just before I get into doing that, I want to acknowledge everyone that I work with at NC State, and Ms. Hazel, some of you have met, as well as our collaborators outside the university, and also funding that we've received through the state, through a bioenergy research initiative, and through other organizations for the work that we're doing. And most importantly, the municipalities. This is not a complete list here of the municipalities that we work with in North Carolina. So in North Carolina, this is largely due to work by Doug Frederick in our Department of Forestry. We have been land applying wastewater to forest since the late 80s and early 90s. And the map at the top shows the different wastewater facilities across the state and the general acreage that are used to do that. And the particular large red dot is the city of Jacksonville, which services about 70,000 residents, and I'll be talking mostly about that site because of its size. And then at the bottom you can see where we have our other sort of conventional wastewater treatment facilities. We haven't been doing a lot of poplar. I'll have to sort of have full disclosure, but we are certainly looking at poplar as a component to these existing wastewater systems, mainly because of the emerging, or actually active bioenergy market in North Carolina. But these are some of the hardwood trees that are out at these sites in different flavors. Some are coppiced, some are not. I would say the majority of these stands are getting towards the end of their effective hydrological use and are in need of being thinned to maintain that great hydraulic process. Okay, for this crowd, we don't need to spend too much time, but I wanted to point out that we're typically treating secondary wastewater, and we're applying sort of an equivalent amount of annual rainfall. So these forests are getting twice the amount of water that they normally would be expected to see. And they still function quite well because of their design for managing nutrients, as well as regulated organics. I've been very interested in how these systems function hydrologically to the surrounding watersheds that they're a part of, and also in particular understanding how they're mitigating non-regulated or emerging contaminants. And then, if they do all that, do it very well, can we have our cake and eat it too, and also produce more energy products for our public market? And this is a nice map, kind of giving you a feel for the wood energy market in the Southeast, which is very vibrant and growing, and raising the price of wood, which is always good for landowners, and making the productivity, in this case with these waste application fuels, to be something that can be of use and could actually break even in terms of being harvested. So here are some pictures from some different water reuse sites across North Carolina with varying different types of hardwoods. And what we've typically found is, yes, they're productive, they're not as productive as if we were doing more intensive managed plantations. But we like them because we consider them liability lands and marginal lands. One of the things that we've encountered is that the folks running these facilities are wastewater operators. They're not foresters, and they're in need of having that silvicultural expertise. Excuse me. On the other hand, our foresters who get contracted to come harvest these sites are not necessarily sensitive to the network, the plumbing network of these facilities, and have been oftentimes quite disruptive. So as a land grant institution, we find that to be an important need for us to meet with our municipalities to help bridge that relationship between those two disciplines. Okay, USDA has a great phrase right now as part of their Water for Agriculture program. And I really am thinking of these systems, their potential scale, as an important means by which, particularly the southeast, we can be preparing ourselves for oncoming climate change variability with regards to water availability, as well as improving water resources. So in the south, we anticipate in the next few decades for our summers to get a lot drier, for our winters to get wetter, and for us to continue to have problems with regards to saltwater intrusion due to over-extraction of water from aquifers. We're in fact already there because of our demographic growth and urbanization, particularly in what we call the coastal plain. So we already have restrictions on groundwater use, and we are requiring municipalities for drinking water purposes to utilize aquifers that are closer and more shallow, and those aquifers tend to have more impaired water quality. Still, with our growing agricultural sectors, we have a confluence of problems with people demanding more water, industries demanding more water, and there's only so much water to go around. So I really see these systems that we're talking about, these forest water reuse systems, as important means not only in the rural area, but in urban areas, as aims to recharge and contribute back to groundwater and groundwater sustainability. So this picture kind of brings all that together with regards to urbanization, and with urbanization will come forest loss. And I'm very interested in us finding these innovative ways to keep forests on the landscape and to have forests working for us. Whether it's managed poplar, I'm fine with that. Whether it's natural forest standards, I'm fine with that as well. So to make that so, we do have to have more information about the services that are being provided by those forest systems, and this is just a general list of what those services could be. And I want to talk more specifically about how these water reuse systems can be important to regulating water quality and water availability. So we're going to come back to the Jacksonville site, which you can see here on your right. It's a fairly large facility, as you saw perhaps in the earlier slide. About 7,300 total acres, of which 2,300 acres are actually irrigated. They're at their capacity, so they have no more land to irrigate. And we're working with this municipality to think about the future, because this is a very growing area in terms of population. And also to rethink perhaps how they're managing the existing forest, which is former Weyerhaeuser land, so it's a mixed pine hardwood forest. In terms of maximizing the amount of water that they can use with their forest system. One of the problems that they face is a lot of water, particularly in the wintertime. We've had a very, very wet winter, and they actually were given a variance to apply when normally they couldn't apply because it was too wet. And that was because simply the lagoons were pretty much at the top, and they had to get rid of that water. What happens to that water? Well, we really don't know. We haven't studied all these sites that we have access to. And I think as we talk about utilizing these sites for various environmental purposes, we have to have that functional understanding about them from a hydrologic point of view, as well as how they actually work with regards to wastewater treatment. So at this site, we do have a populous trial, and I think this gives you a good idea of what the site looks like in the wintertime. It's pretty wet, and that's simply from normal rainfall. But it certainly dries out, as other people have noted, in the summertime. And they have to be bedded sites in order for the trees to really get started. And that would be true if we were putting in other types of tree species, pine or hardwood. So the actual bedded sites are noted for you, but we planted poplars in between because we wanted to see how they would do. They were even in more inundated environments, and they actually have survived, which is the important part. They certainly didn't grow as well. Oops. Well, that's a shame. I didn't see that one. Oh well. What's going on here are basically the black. We tell you that the bedded series, which is 3 different clones, do better than the non-bedded. So what are some of the limitations in terms of that productivity if you're really trying to think about getting things grown for a bioenergy market? One would be probably a better genotype selection, which we would like to work on. Because you're irrigating and it's the south, weed competition is a really big problem. And the other issue here is secondary treated wastewater. Not necessarily because we don't do the biosolid application, This water isn't actually really that nutrient rich. And what we have done is move forward to look at yields that we can get from primary wastewater application. And so here we do have some better genotype material that we're working with, and these trees are also 2 years old, and they've done really well in terms of their productivity, particularly for the deltoides. So this, we feel, is a really break-even productivity possibility in our area for the wood pellet market. And that primary wastewater simply has just not much more nitrogen in it to make it worthwhile for growth. So overall, for these wastewater application systems, you might expect not to get the productivity you want because permits require that you have understory growth, whether it's grasses or shrubs, and that's obviously going to compete with your trees for productivity. But personally, I think that's okay in terms of the other associated services that you get. Some of the concerns I have would be having a more frequent harvesting period. I think we tend to think where we are in our neck of the woods of harvest rotations are in 10 years or up to 20. Just having that equipment out of these sites and the logistics of that, I think would pose problems to the actual functioning of the facility. Okay, so the last thing I want to talk about is how these systems work compared to conventional wastewater treatment plants, or what we call our non-regulated organic contaminants, which in the future may be regulated but aren't regulated at the moment. And we tend to think of these things as pharmaceutical products or personal care products. It also includes newly developed industrial products that haven't gone through the whole regulatory process for acceptance. So again, we're back at Jacksonville, and we've been studying and getting preliminary data pulled together for what's at this site coming through the wastewater system, what happens to these chemicals once they're land applied and where they go, and more importantly, down here at the bottom where you see the word outlet. That is the sub-watershed surface water discharge area. And so what do we see in that water with this year-round annual application of wastewater? And there's a lot of uncertainty and lack of knowledge about these chemicals, how they function in the reservoir systems, where they usually spend 7 to 10 days. And then certainly what happens to them once they are infiltrated the soil through the irrigation process, in groundwater, and eventually making their way into surface waters. So the first thing to understand is that the wastewater itself changes throughout the year based on what people are using. And what this chart shows you is that in the hotter, drier times of the year, people aren't as sick with colds, and so they may not be using the same types of drugs and personal care products as they would during the wintertime. And so what you're looking at is just a general profile of the analytes that we measure that we put into major categories between hormones, caffeine, plasticizers like bisphenol A, and NSAIDs and antibiotics. So we lose this material in the reservoir. Why is that? It seems that it might be due to photodegradation. It's sunnier and warmer then. It could be that you're growing a lot more algae in that pond and you're getting biodegradation from that, as well as perhaps sedimentation. It could be a factor of pH. With all that algal growth, during the day you get huge fluctuations in pH. And that could drive the dissipation of some of these compounds. We actually can't be specific to those mechanisms yet. This is what happens to the stuff as it goes out into the forest and is land applied and irrigated. And so the top left panel is what's in the wastewater, and then this is what we have measured in soil, both at depth, but we've aggregated it here just the soil itself. And then this is typically what we find in the groundwater beneath the site. And what this follows basically is that those chemicals that are more water soluble tend to be the chemicals that make it all the way into the groundwater, and those chemicals that are less water soluble tend to get trapped in the soil, particularly in surface soil. And over time are biodegraded and stored and removed. Okay, and when does this happen? Is this sort of constant release and processing? And the truth of that is no, these are really large systems that you're loading with water fairly routinely, but then we have large rain events that occur. And when we have really large rain events, you'll get flushes from this entire system of these chemicals into the surface waters. The other important time when you get the greatest amount of these chemicals released is during really dry times when we haven't had much rainfall. And that's because the base flow and discharge to the surface waters from the groundwater is mainly irrigated wastewater. But the bottom line is what comes out of this facility at the end of it from the surface water discharge? Do they export these organic chemicals? And the truth of that is yes. On this chart at the top, the yellow X, you can see what's coming into the watershed where the irrigation occurs. And the purple X is sort of in the system itself, and the green X is what's coming out through the outlet. And we are gaining these different types of products. Some products are being introduced to the system from upstream, and we're certainly adding to them as they leave. The important point here is the concentrations. So if you look over at the x-axis, you have nanograms per liter. A lot of these chemicals, when you take them, you're taking them in much greater concentrations. So this is really about 2 orders of magnitude lower from a human health risk point of view. And so these systems are functioning with regards to removal. And that's sort of what this table kind of summarizes for you. This is comparing what we've measured in soil, groundwater and surface waters to what's been measured downstream in conventional wastewater treatment plants. And you can see that for these forest water reuse systems, they either function as effectively or even are doing a better job. And some of that, of course, is due to the fact that what you're land applying onto the 2,000 acres at the site gets diluted within the larger watershed of 6,000 acres. So we're fortunate in North Carolina to have these systems in existence. Most of them have been operating for 20 years, and so it's good to come sort of in their midlife and see how they function and to understand better how they work hydrologically as well as treatment for organic chemicals in particular. They're certainly meeting the permit requirements for metals and nutrients and regulated organics. And one of our questions is, if we understand and can model these systems better, can we then optimize them to achieve different environmental results? And we utilize them, particularly in the wetter periods of the year, to store, in a sense, groundwater,